Ksp practice question. This question over here, wherever MgOH2, I have it here. I'm going to be breaking that down into its constituent anions and cations, which I've done. Mg2 plus has a charge of 2, and then this, obviously, this OH minus has a charge of -1, so I put that over there. But there's obviously 2 over here, so I'm going to be putting 2 over there to not violate the law of conservation of mass. I've just balanced it. So then from here, I just put 2x, and I continue to go downwards and carry it down. We also know that our Ksp formula is equal to our concentrations of the products multiplied by each other. So I've done that over here. Mg2 plus is just x, so I put that over here. Remember that whatever coefficient is in front needs to be raised to that power. So if there's a 1 over here, technically there's a 1 up there. OH minus has a coefficient of 2, so that becomes a 2 power up there. So I just expand for my x's. I end up getting this. Obviously I got to divide by 4 and then cube root it over here. If I do it on the right side, I got to do it on the left side. So I get my concentration over here. So I have my concentration over here. I have my volume that I'm supposed to get. Again, this is per liter, right? Moles per liter. I don't want just 1 liter. I want 0.3 liters, so I've written that over there. I don't have my N, so I have 2 out of the 3, so I can easily use my C is equal to N over V formula. I isolate for my N, I get my moles, okay? I want to convert my moles because I want my mass of the OH2, not the moles. So we just find the molar mass of our MgOH2. It's 58.3197. Cancel out the moles, I get my grams, so then I end up getting this as our answer. In this question over here, I have Ag2CrO4. That's the one I want to revolve around because that's what the Ksp is for. I don't really care about this compound over here. All I know is that I got this CrO4 from this sodium chromate over here. Where did this Ag plus come from? We don't know. It could come from any other AgCl or any other anion. We don't know, but that doesn't really matter. We're going to revolve around the silver chromate here. Okay, I'm just going to balance it out. 2 over here, just 1 over here. So obviously this becomes 2x, this becomes 2x. Do not forget that this CrO4 has to be 0.05, because that's written in the question, okay? The CrO4 is in both, right? Both the sodium and the silver. So I'm going to be putting our Ksp is equal to these two products multiplied by each other. This obviously becomes 2. This one has only one coefficient, that's a 1 there. I continue to bring down this 0.05 over here, 0.05 over here. I isolate from x, I end up getting this value for my molar solubility. If you want to know more in detail as to why this 0.05 is actually applicable as CrO4 minus as the anion as opposed to this whole Na2CrO4, it's kind of written here, but if you want a more in-depth explanation, see the 20-minute video. The link is in the description. These are the 2 green questions of the day. All right, this here is the first one, this here is the second one. Please try these on your own and I'll be giving you the answers shortly. Pause the video. This is the answer to the first question. This is the answer to the second question. I will slowly scroll down.